Hello students, let us start with the chapter number 11, Dual Nature of Radiation and Matter. Let us understand or let us go through the basic concepts and the inventions has been done by a well-known scientist. Here the Maxwell tried to generate and calculate the components of electromagnetic wave and derived four equations which is well known as Maxwell equations. X-rays are invented by Röntgen. Electrons are invented by J.J. Thomson. Hertz has done some of the experiments on electromagnetic waves to generate and detect its wavelength. Cathode rays are discovered by William Crookes. Cathode rays consisted of streams of fast-moving negatively charged particles which carry the current. So electricity has been possible due to that free charge carriers. If these electrons are passing through the discharge glass tube at low temperature about 0.001 millimeter of mercury column, then discharge has been takes place from the cathode grid by applying the electric field, and that generated electrons are attracted towards anode terminal, which is a positive polarity. While these electrons are flowing from cathode to anode, so at that time the fluorescent color can be produced. Generally, that color generated depends on the type of glass. For example, yellowish green color would be generated for soda glass. Now, J.J. Thomson itself again measured the charge to mass ratio for the specific charge on the specific frequency by applying electric field and magnetic field perpendicular to each other along with discharge tube. So within that discharge tube, the speed of this charges are about 0.1 to 0.2 times of speed of light, and E by M ratio is measured by the value 1.76 into 10 raised to 11 coulomb per kilogram. This E by M ratio is independent of the material and based on that gas introduced in that charge. Here, as we know, value of the charge is 1.6 into 10 raised to minus 19 coulomb. So if we know E by M ratio and charge of the electron, then we are able to get the mass of the electron. Then Millikan has been done some of the experiments to define that electric charge is not continuous, but it is a quantized, it is discrete. Now let us understand that what is electron emission and how these electrons are generated from the cathode grid. So here, as you can see in the diagram, one metal plate has been taken over which if light signal is falling on it, then free electrons are generated. They gathered onto the surface of that metal. If these electrons receive enough energy from the external field, they will energize, and coming out they try to attract towards that external field compared to the positive charge present within that metal. So based on that, this more attractive force is provided externally and electrons are coming out from the metal surface. That process is basically known as electron emission. For that, these electrons, so here this attempt to coming out from the metal surface and this attractive force are higher than the positive charge present within the metal. These free electrons are inside the metal itself, as a metal has already large number of free electrons are there. They gather at the surface. So here this minimum amount of energy is required to make this electron free and come out from the surface. So this minimum required energy to make this electron escape to come out from the metal surface is known as work function, which is denoted as a phi 0 and measured in electrovolt. So here 1 electrovolt is the energy gained by an electron when it has been accelerated by the 1 volt potential difference, and 1 electrovolt equal to 1.6 into 10 raised to minus 19 joule. This work function, it depends on the property of metal and the nature of its surface. So here work function, it is also sensitive to the surface impurities. Here one table is given. It shows that work function value is constant for a specific metal. Now here basic 3 processes are there which we are supposed to follow for this electron emission. The first one is thermionic emission. For that we are providing suitable heat which generates a sufficient amount of thermal energy. By gaining that thermal energy, these electrons becomes free and unable to make them coming out from metal surface. Next process is field emission, in which we are applying very strong electric field which is in order of 10 raised to 8 volt per meter, and electrons pulled out from the metal in terms of spark plug. Third is photoelectric emission, in which suitable frequency of light signal is illuminated onto the metal surface and electrons are emitted from metal surface. This generated electrons are known as photoelectrons. So now let us understand this, how this photoelectric effect would be there, which is experimented by Hertz, and he observed certain conditions. That here he had done some experiments in 1887. During his experiment, actually while he was doing electromagnetic wave generation and detection at low pressure, so at that time he observed spark, high voltage spark across the detector at the emitter plate, while that emitter plate is illuminated by UV light. So when this particular light is falling onto the metal surface, electrons near the surface absorb that sufficient amount of energy and attracted towards this external energy, then these electrons coming out and generate this spark. So here these electrons are absorbed and coming out. So based on this experiment, other two scientists have observed some similar kind of observation, that Leonard observed for ultraviolet radiation, this allowed to flow on emitter plate in a glass tube when current is flowing. So here if UV light is not falling on that, then current won't flow. While that ultraviolet light falling over it, then from the emitter plate electrons are generated and evacuated towards the glass tube and current will flow. So here we can say that photocurrent is varying with collector plate potential and with frequency and intensity of incident light. So here these parameters are there on which photoelectric current is affecting the potential, externally given potential at collector plate, frequency, intensity and matter. So this metal condition has been observed by Halox. He observed that if as a collector plate zinc material has been used, so that is only sensitive with the UV light, and based on that, as UV light is falling onto the zinc plate, then charge carrier will generate, which makes uncharged zinc plate to positively charged. And if this zinc plate is already positively charged, then make it more positive. And based on that, how this plate can become more positive, as number of electrons coming out, emitted out from that zinc plate. So that zinc plate itself becomes more positive, and that zinc plate is only sensitive to UV light. So here this incident light caused the free electrons and coming out from that emitter plate. Due to this negative charge, this emitted electrons pushed towards the collector terminal anode and generate the photoelectric current within that given electric field. Here, when this UV light is falling over it, which requires minimum frequency, depends on the nature of that material. For example, zinc, cadmium, magnesium depends that responded only UV light, and alkali materials such as lithium, sodium, potassium are sensitive to visible light. So here we can say that emitter plate over which light signal is falling, then electrons are generated. When no ultraviolet light is there, then electrons are not emitted out. So here each material is sensitive to that specific frequency which require that frequency signal only. That minimum required frequency is known as a threshold frequency. If onto the lithium plate, if the UV light is falling over it, then it will not sensitive to it. So below that threshold frequency, if any light signal is falling over that metal plate with the high intensity, even though electrons are not generated. After that threshold frequency only, if any frequency of that signal is falling onto the metal plate, then only intensity of that light signal can be affected. So this minimum required frequency is known as threshold frequency, and that phenomena, these generated electrons are known as photoelectrons, and current generated by that photoelectrons is known as photoelectric current with the effect of photoelectric effect. Now let us understand how this photoelectric effect is generated by that some circuit arrangement. So as you can see over here glass plate is available, which is a sensitive plate which is available nearby to the photosensitive plate cathode, and another plate we have utilized, that is anode. Now here the monochromic light is available from the source which is having a specific wavelength which is passing through the window of that glass window and falling onto the cathode plate. Here from that window, if UV light is passing through it and it is radiated towards the cathode plate, then electrons are emitted by that cathode plate. That generated electrons are collected by the anode. This current is only possible when the potential difference between cathode and anode is provided by external electric field by that given battery. This battery maintains the potential difference between cathode and anode. If the polarity of the plate can be reversed, for that commutator has been used. So here generally plate A defines with the positive potential and plate C defines for negative potential. So electron emission which cause the flow of current in that particular circuitry. This current can be measured by microammeter and its voltage can be measured by voltmeter. This photoelectric current can be increased or decreased by potential voltage available at emitter plate. If we change, if we vary the intensity and the frequency of that incident light, so as that also can change the photoelectric current in that glass tube. Right. Here we are going to end this session. Hope you understood. Thank you.